The topic for today is long division. We use long division to be able to simplify a division of two polynomials or two functions. As you may recall, we can take f of x, a function, and divide it by another function, g of x. And up to this point, if we take f of x, say x squared plus 6x plus 8, and divide it by g of x, which say x plus 2, we allowed you to leave it in this form. Today, however, we're going to be able to take and perform this operation using long division. Before we get into polynomial long division, let's recall numeric long division. Let's say we want to take 15 and divide it into 20,348. To use long division, we ask ourselves, how many times does 15 go into 20? In this case, it's one time. Take our 1, multiply it to 15, we get 15, and we subtract. 20 minus 15 gives us 5, and we bring down the 3. We then ask ourselves, how many times does 15 go into 53? That would be 3. 3 times 15 gives us 45. Subtracting 53 minus 45 gives us 8. Bring down your 4. And now we ask ourselves, how many times does 15 go into 84? Well, if 15 times 3 was 45, we're going to try 5. 5 times 15 gives us 75. Again, we're going to subtract. 84 minus 75 gives us 9. Bring down our 8. And now the question becomes 15 goes into 98. How many times evenly? That answer is 6. 6 times 15 gives us 90. And we subtract gives us our 8. Now, as you got older, you added decimal places and added zeros. When you were young, we simply put an R with our remainder. And that's actually the way we're going to leave it so that we can use it for our polynomials. So let's go ahead and look at dividing these two polynomials using long division. So I'm going to leave my f of x and g of x up here. My x plus 2 goes outside of my division bar. My x squared plus 6x plus 8 goes inside. And we're going to ask ourselves the same question, but we're only going to use the first term of our outside polynomial. So we ask ourselves, what times x gives us x squared? And the answer would be x. The placement up here, not as critical as it was down here within our numeric long division. So you can place that wherever you want up there. Normally, we place it over the same term, so that x really probably should go over here. Multiply your x to your x plus 2, the whole polynomial, gives us x squared plus 2x. As in our numeric division, we're going to subtract. Remember, when we subtracted polynomials, we had to distribute the negative, so we're going to distribute that to both of our terms. And we're going to add down x squared minus x squared gives us 0x squared. 6x minus 2x gives us 4x. And we can bring down the 8. Now we ask ourselves, what times x gives us 4x? And the answer is 4. 4 times x, 4x, and multiply the 4 times 2, which gives us 8. Again, distributing the negative, which changes our signs. 4x minus 4x is 0. 8 minus 8 gives us 0 as well. So we have no remainder. So our answer is simply x plus 4. This allows us, since we have no remainder, to say that x plus 2 is a factor of x squared plus 6x plus 8. So x plus 2 is a factor of x squared plus 6x plus 8 because there is no remainder. Later on, we'll look to see that there is one that is not divisible, not a factor. So let's look at a second example. And let's get a little more complicated. For example 2, let's take x plus 4 and divide it into x to the third plus 3x squared minus 6x minus 7. We're going to ask ourselves the same question. What times x gives us x to the third? And that is x squared. X squared times x plus 4 gives us x to the third plus 4x squared. So we're taking this term, multiplying to each of these two terms, placing it below what we're dividing it into. We're going to change our signs or multiply that negative through, distribute. X to the thirds cancel. 3 minus 4 gives us negative x squared minus 6x, bringing down that 6x. We ask ourselves, what times x gives us negative x squared? In this case, it's a negative x. So negative x times x gives us negative x squared, and negative x times 4 gives us negative 4x. Again, changing our signs, we'll see the x squareds cancel. The 6x plus negative 6x plus 4x gives us negative 2x minus 7. As we bring down our minus 7, we ask ourselves, what times x gives us negative 2x this time? We get negative 2. Negative 2 times x is negative 2x. Negative 2 times positive 4 gives us negative 8. Changing our signs, again, we should see this first term cancel out, which it does. Negative 7 plus 8 is 1. So we get a remainder of 1 since x does not go into 1. If we ask ourselves what times x gives us 1, we couldn't answer that question. So we have a remainder 1. Since we have a remainder, we know that x plus 4 does not divide evenly, or is not a factor of x to the third plus 3x squared minus 6x minus 7. And that concludes our example 2. In example 3, we get actually a little more complicated for the fact that our problem needs to be altered to begin. Here we're going to take x to the third minus 1 and divide it by x minus 1. Notice what we're dividing it into, our x to the third minus 1, does not have the squared or the quadratic term or a linear term in x to the first. We need to actually place those in before we can write out our division problem. So when we write it out, we have our x minus 1, and we're divided into x to the third. We need to insert our quadratic term. So the way we're going to do that is plus 0 x squared. We need to add in a linear term, so 0 x to the first minus 1. Notice how my exponents decrease by exactly 1 each time. As was the case in example 2, we already had 3, 2, 1, and no x's. Now the problem becomes just like example 2. We ask ourselves the question, what times x gives us x to the third? And that is x squared. X squared times x gives us x to the third, X squared times negative 1 is negative x squared. Changing our signs, we end up with x squared when we add, and we bring down a 0x. X times x gives us x squared. So we can multiply this out and get x squared minus x. Changing our signs, we notice our first term cancels again. Adding these two terms, we end up with x. Bring down our minus 1, and we end up with x minus 1. So now the question is, what times x gives us x? And that is 1. 1 times x is x. 1 times negative 1 is minus 1. Change the signs, we end up with 0. So again, we have no remainder. So x minus 1, we say, is a factor of x to the third minus 1. And there's our answer. And we have one last example, example 4, to show. And this one I wanted to show for the simple reason that we start out with a leading coefficient within our problem. If you recall, all of our other problems started out with a 1 as a leading coefficient. Here we have 9. Doesn't make the problem much more complicated. We simply ask ourselves the same question. X times what is 9x to the third? And we get 9x squared. 9x squared times x is 9x to the third. 9x squared times negative 5 is negative 45x squared. Change your signs. First term cancels. Add these together. We get a negative 3x squared plus 13x. Same question. X times what is negative 3x squared? And that answer is negative 3x. Negative 3x times x is negative 3x squared. Negative 3x times negative 5 is a positive 15x. Change the signs. 13x minus 15x, we end up with negative 2x. Bring down the 3 plus 3. We ask ourselves, what times x gives you negative 2x? The answer is negative 2. Multiplying negative 2 to x minus 5, we get negative 2x plus 10. Change your signs. 3 minus 10 gives us negative 7. The linear or the x terms cancel. X times what is negative 7? We don't know that answer, so that is our remainder. So we have r, negative 7. In example 5, we're going to change the divisor from having a leading coefficient of just 1 to now having a coefficient other than 1. And our dividend is going to be 2x squared plus 5x minus 7. We're going to again ask ourselves the same question. What do you multiply 2x by to get 2x squared? And that answer is x. X times 2x gives you 2x squared. And we'll multiply that x to the other term, 1, to get a positive x. Change the sign. We have 5x minus 4 minus x gives us 4x minus 7. Completing the process, 2x times what is 4x? That answer is 2. 2 times 2x is 4x. 2 times 1 is 2. Change the signs. We get negative 9 and no x's. 2x does not go into negative 9, so that is our remainder, negative 9. So we say that 2x plus 1, the divisor, is not a factor of the dividend 2x squared plus 5x minus 7. And that concludes our long division lesson.